We introduce Heimdall, a remotely controlled inspection workbench for debugging microcontroller projects. Heimdall allows for the student to use the same workflow for breadboarding electronics, but gives a wealth of tools for an instructor to remotely debug the physical hardware. First, Heimdall captures the visual information of the student circuit by taking 360 degrees of photos at various elevations. This cache dataset allows for an instructor to quickly and intuitively get a sense of the physical layout of the board. The system also allows for the remote debugger to switch to a live video feed from any given still view. Heimdall also allows for deeper control and understanding of the underlying electrical circuitry. The remote debugger can select a row of the breadboard which they would like more information about. They can determine if a signal is high, low, or measure the analog voltage of any row. This information is available in instantaneous readings or in a graph over time. 8 simultaneous measurements can be made. If the instructor needs more control over the student circuit, they can also isolate components and inject signals as well. By clicking on the area between a row, the row splits in half, isolating components to be debugged individually. Heimdall allows for a user to inject a high signal, a low signal, or a square wave. Heimdall's features can be used in combination to help understand the student circuit. In this case, the instructor isolated a component, injected a square wave, and also used the live view to see the result of their injection. In this next example, the student is printing the analog input of a potentiometer to the serial console. We see the serial messages live and can understand the inner workings of the microcontroller with it. To simulate the potentiometer being adjusted, we can dynamically inject an analog voltage into the input pin of the microcontroller. We now see the serial output of the student microcontroller being changed by the debugger's input. Heimdall can be combined with existing technologies to extend functionality. By connecting accompanying open source hardware such as the Bus Pirate, Heimdall can be used to sniff I2C communications.